Hi, welcome to Java Coding Assist. In this video, we are going to see how to secure a REST application using Spring Security. Each incoming request to the REST application comes with all the information to authenticate the user from whom the request is, and it also contains information to check whether that particular user is authorized to access that resource. The login information about the user will be stored externally in a database, and whenever the request comes in, the authentication information is taken from the request and it is verified across the data that is stored in the database. Let's go in and see how this is implemented. Using Spring Security's user detailed service. Let's start by creating a new Spring Boot application with all these dependencies: Spring Web, Spring Data JPA, because we are going to use database here. Our data are going to be persisted in a persistent database. So we are going to use Spring Data JPA. And I'm going to use the H2 database. It's an in-memory database which exists within the Spring Boot application. You can use any database here. And finally, the cloud security and dev tools. I have imported that sample application here, and this is a simple REST controller which is having two endpoints, users all and users details. The all is going to retrieve all the users from the database and returns it. The details endpoint returns the details of that particular user who has been currently logged in. To make this work, we need to create the user object and the user service and user repository to access the data from the database. That is to retrieve the users from the database. This is the user object. It has four fields: user ID, username, password, and role. Each user will be having a role, and only based on that role, the user will be authorized to access the resources. This is the repository that is created for the user object by extending the JPA repository. It takes in the user object, and this integer is the data type of the field that uniquely identifies the user object. Using this repository, we will be able to talk to the database. Actually, here we create only an interface. We do not write that implementation for this interface, and it is handled by the Spring. Spring creates an implementation for this interface with all the default methods like save, delete, update, find by ID. Like that, it will create all the default implementations. And here we have declared one method, that is find by username. Even for this method, Spring will automatically write the implementation. This is the advantage of using JPA repositories. Username is a field in the user object, and we are going to retrieve an user by the username. Spring will automatically do this implementation. And if you have any doubt regarding JPA repositories, you can just check another video that is on Spring Boot applications with JPA repository. The link is in the description box. This is the user service that belongs to the service layer. We have auto-wired user repository here, through which our service talks to the database. The request comes to the controller, and the controller calls the user service, and the user service talks to the database through this user repository. This service contains methods to get all the users, find an user by ID, and also methods to save an user, update an user, and delete an user. Now we can see the database configurations that is done in applications.properties file. you can write the applications.properties file inside the resources. So the first one is the URL of a data source. As I'm using an in-memory database, it exists within the application and it is available in the same port on which we are running the application. That is in-memory. TestDB is the name of the database. Next is the driver. Since we are using H2 database, it is a H2 driver and my username is SA and I haven't given any password. If you want, you can just mention some password here. And the final one is the dialect. And based on that dialect, JPA will automatically create the queries that is specific to the database. Since we are using H2 database, here we have mentioned as H2 dialect. So queries will be created for H2 database. This show SQL is used for just logging purposes. Whenever there is a database access, the query that is generated will be shown here in the console. And the second one is this Hibernate format SQL just format that query and shows it in the console. And next is the DDL auto. Here I am using an in-memory database that is H2. As this is an in-memory database, whenever the application is shut down, the database will be automatically deleted. So I'm just writing it here as create so that the database will be again created when the application is started up and running. If you are using any other database other than in-memory database, your database is already existing. So you can just write update instead of create, which implies that the database is in update mode. That is, the database can be updated by our application. Next, these all are H2 related information because H2 database will be in the same place where the application is. So if the application is running at port 8080, this database will also be available at 8080. When the H2 console enabled is set to true, the H2 console is available to you and it is in the path H2 console. If you are using in-memory database like me, then you have to populate that in-memory database using some datas. You can do this by writing an SQL file, that is data.sql, where you can just write the insert queries to insert data into the database. You can write as many as insert queries and you can just insert it into multiple tables also. If you are not using in-memory database, then you can skip these portions like using the data.sql because your data will be already existing in the database. You have to just modify the data source information in the applications.properties file. Next comes the security part. To configure the security for our application, we need to extend the web security configurer adapter and override 3 of its methods. The first one is authentication manager bean. We have to return the authentication manager bean from the superclass and then we need to configure the authentication manager builder here. So we have to tell the authentication manager that we are going to use the user details service of Spring Security to authenticate the user. Auth dot before we did in-memory authentication where our user's credentials are stored within the application. But now we are going to use the user details service of the Spring Security. When we use this user details service, we just say the authentication manager that user service details is used to authenticate the user. This user details service is an abstraction. We have to implement it. We have to write the implementation for the user details service. This user details service is given by Spring Security in order to maintain a contract. So whatever may be the user object, this user details service will retrieve that user object from the database and it will convert it into a user details object which is specific to Spring Security, and that is done in this user details service. That user details object will be used by the Spring Security to authenticate the user. So whenever we are using this user details service, we have to write two implementations. We have to implement the user details service and the user details object. Let's see how to do that. Let's now see how to implement the user details service. This user details service is an abstraction with only one method. As we have configured the authentication manager to use the user details service, whenever the request comes in for authentication, Spring Security will call the load user by username method of user details service. So here we have to implement our logic to retrieve the user from the database. So we are using the user repository here and find the user by the username. This username is retrieved from the request header, and the user repository is used to retrieve the user by the user name. So if the user is null, that user doesn't exist. So it will throw a username not found exception, and this exception is handled by the Spring Security, and the response to that request will be a 401 and authorized. If the user exists, that user object which we retrieved from the database is converted into user details object of Spring Security. This user details object is used by Spring Security to authenticate the user, and also this user details is encapsulated into the authentication object and the principal object, so that later when you want to know which user is logged in, or to get the information of the logged in user, you can make use of this authentication object or the principal object to retrieve the user details, from where you can just get the username, password, and also the roles of that user. Now we can see how to implement the user details object. This is the user details objects implementation. We have to create the user details object from the user object which we have in our application. Now we can see some of the fields of the user details object. It has a username. It will return the username which it gets from the user, and password. And next is the role of each user. Each user will be having a role, and only based on that role, that user will be authorized to access the resources. So each role from the user object will be converted into a fine-grained authority, that is called as simple granted authority. So you have to create a list of authorities from the roles of each user, and based on these authorities, the user will be authorized to access the resources. While creating the simple granted authority, you have to be specific about the granted authority name. That is, the simple granted authority should be prefixed with an uppercase role followed by an underscore, and the role, actual role, maybe admin, user, the whole thing should be in uppercase, and it should be prefixed with role underscore. If you check my database, I have stored the roles as just admin, user. So what I am doing is, I am just prefixing it with an uppercase role underscore, and then I am just converting my role into uppercase, so that now it will be role underscore admin or role underscore user. Only these authorities will be identified by Spring Security. If it is in lower case, it doesn't work in all the cases. Or you can directly store the role in database as role underscore user, role underscore admin. If you are storing it this way, then you can skip that part in simple granted authority. You can just directly get the role from the user object and then create the simple granted authorities. There are some fields which need to be set to true because this account still exists. This user still exists. Is account non-expired? It has to be set to true. and is account non-locked, is credentials non-expired, and is this user still enabled. All has to be set to true. And finally the get user details, which returns the user information. Now we are done with the user details object and the user details service. Now we have to go to the web security configuration to tell the authentication manager to make use of this user details object. We are back again to web security config to configure the user details service to the authentication manager builder. So we have to auto-wire the user details service which we created before here into authentication manager builder. Along with the user details service, we have to pass the password encoder for the Spring Security to decode the password. So whenever the Spring Security retrieves the user object from the database, it uses this password encoder to decode that password and then authenticates the user. For this, we need to first encode and store the password in the database. For this, we need a password encoder B, which returns a password encoder. Here I am using the password encoder factories to create the password encoder. This password encoder factories is a factory of password encoders. It has a list of password encoders which can be used by Spring Security. Whenever you are using a password encoder, you have to prefix the name of the password encoder along with the encoded password. This is my H2 in-memory database and here is my user table. This is how passwords have to be stored. This is the encoded password and this encoded password is prefixed by the name of the password encoder I have used to encode this password. This is a format to store the passwords in the database. When using an in-memory database, the database also runs in the same port as the application. We are securing the whole application, so access to this H2 console will give you a unauthorized or forbidden message. So you won't be able to access the H2 console. So what we have to do is we have to tell the web security to ignore this path so that we can access our H2 console. If you are using any other database other than this H2, you won't be having any problem. So we have to configure the web security to ignore this path H2 console so that we will get an access to this in-memory database. This configuration is also done in web security config that extends the web security configurer adapter. The application is up and running. Let's now check whether we are able to access the H2 console. Yeah, now we are able to access the H2 database. This is your H2 in-memory database. It has the user table. Now the application is up and running. As this is a REST application, we can use Postman to test this application. The users all endpoint will return all the users from the database and the users details will return the details of the user who is currently logged in. The application is running at port 8080 and this is the users all. We can call the users all endpoint. Now we are calling without any authentication details, that is without any username and password. We get a 401 unauthorized response. Let's now send the username and password along with the request. We have to choose the basic auth from the authorization tab and then we have to give the username and password of the user. Now we got the desired output. It just returned all the 3 users from the database. Let's check the other endpoint too. Users details. The same username and password. It returned the details of the user Sam. Let's check with another user. Yeah, we get the details of the user Gabby now. Without this authentication details, our request will not be authenticated and you won't be getting the response back. Let's resend the request again without any authentication information and check what's the response. So now we get an unauthorized response. Each and every request must contain the details to authenticate an user. Only then you will be getting a response from a REST application. That's it for user details service of Spring Security. Let me know your thoughts in the comments section. Thanks for watching. Bye.